Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap today, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to access it on demand. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during our presentation you have a question for either of our panelists, don't wait, don't hesitate, just use your GoToWebinar control panel and submit your question. And we'll take about 10 or 15 minutes near the end of the presentation and go through those questions. Okay, with that, we will kick off today's webinar, which is So You Want to Provision a Test Environment. Our speakers today are Eric Minick, who is DevOps Offering Manager, Hybrid Cloud at IBM, and he is going to be joined by Bill Stoddard, who's Program Director, IBM Cloud Automation Manager, also at IBM. Welcome, gentlemen. Thanks for joining me today.
Thank you.
Excellent. Well, I'm going to go ahead and I'm going to put myself on mute, let you guys get to it.
All right, thanks for the introduction, and thank you all for joining us. I think about this kind of test environment question, and I think back to an experience I had in London, of all places. I was talking to some folks who work at a bank, and they were all really proud of how they had this self-service VM system where you could push a button and get a VM, and how it was going to speed up development. So I asked the better question here. So you have a new team and they need a test lab. How quickly can they get a test lab, right? The self-service thing can get them a VM in a couple minutes. Is it like 20 minutes and you have a test lab? And they said, no, it's more like 4 months. And that was surprising. And the really interesting thing is I had the exact same conversation a day later at a different bank in London. So what we want to do in this session is take a look at what it really takes to get a test environment and the tool chains involved there, because it's a little more interesting than I think a lot of people realize at first, because an empty VM is not a test environment. So, I think the first place people go from is it just a VM is, well, actually, it's a bunch of VMs, right? I need a bunch of VMs. I need to connect them with a network and attach some storage to it. So all of the computers that represent my application for a couple of web services and a database, they're all there, right? I need an infrastructure template of some sort, right? And this is where we see Terraform and Cloud Foundations and all of these things playing. But, if you actually had a tester, like, go try to hit one of those IP addresses, there wouldn't be anything there, right? You just have some empty VMs that are wired up together. So that's a problem. So then you say, well, if we're going to have some web apps and some databases here, then we probably need to install some web servers and have some users to run those as, and install a database there, right? Okay. We're going to solve that. Again, if you then go hit the IP address at the port where your web servers are running, you're still going to have a page not found because there's no application actually running out in those servers, right? So, okay, so if we've started with something like Terraform, we run some automation, maybe it's a big fix, maybe it's a Chef, a Puppet, and Ansible to get all the middleware installed. It's still empty. Oh, bummer. All right. So we bring in like a release automation tool, right? And we put the application out there. Cool. Now when our tester goes and hits the application, at least the application comes up, but when they put in the standard, username and password, they can't actually log in, right? because we haven't attached any of the test data to it, right? There's no users in the database. If they were able to log in, there wouldn't be much there, right? So that's not terribly useful still. But it's better. I mean, we can at least see that a screen comes up, and I guess that's a smoke test, right? You turn it on and you see if smoke comes out, but it doesn't get you a lot further than smoke testing. All right, so we need data, right? And so there's someone who's like, well, there's data in production. We'll just copy the data from production and we'll put it in the test environment. And there's things like copy data virtualization and kind of tools in that space that can really cleverly move some data around. But if you just move that data straight, there's going to be some production data that's sensitive that you don't want in your test lab, and probably puts you in GDPR trouble and all sorts of things like that. So you need to clean that up, right? So that the data needs to be either generated rather than copied, or if you're going to copy it, you need to obfuscate it along the way, right? So this is where full-on test data management tools really play, right? Because they're going to be able to clean up the data for us. Now we're in a point where we're pretty good. We can spin up all of our infrastructure and get the application in and get the data. But a huge number of the applications out there, if you're testing against them aggressively, become very expensive because they're making some API calls to things outside of the immediate application that are expensive. Maybe it's some stock trading app and you're pulling stock data in from the exchanges and you're charged per call there. Maybe you're reaching back to a mainframe and you're consuming MIPS. There's a million ways that these things can become expensive. And so managing these APIs that you might not need the live data on is really key. This is where a lot of people will use mock objects and things like that. The product approach to this is a technology called service virtualization, where you impersonate these APIs really quickly and easily. And that helps you manage those external dependencies. Now, at the same time, you're going to have situations where the test lab goes down, particularly on those teams where the testers are often some other geography. That you get these situations where no one notices that the test lab was down all day until the team that's offshore comes and starts testing, and they're spinning their wheels trying to find someone to get it back up. So you need to build around those test labs and get kind of that management layer, the monitoring built up around that. So this kind of gets to more of what you actually need in order to get a test lab, right? You're going to need to be able to provision your infrastructure, get the middleware installed, get the application installed into that, populate the test data nice and clean, deal with your external dependencies by virtualizing those away, and then making sure you've got your management and monitoring layer. So it's kind of the big picture, and that's what we're going to be talking about today is how do we tackle this. So I'm going to talk a little bit about how the tool chain strings together here in a second. Then Bill will talk through some of those top items around infrastructure and server configuration, because that tends to be the biggest chunk of the work in getting the test environments going, is just flat out getting good infrastructure in place, taking advantage of cloud and clouds, plural. And then we'll circle back into some more detail around the bottom half of this list and wrap it up with some questions. And that said, we are definitely planning on some time for questions here at the end. If you don't ask any, then Bill and I will talk amongst ourselves. But this session will go a lot better if you ask questions. So let me talk real briefly about the tool chain. So first piece here is for that top infrastructure and server config. Whether you're going commercial or building your own, you're putting together what's typically called a cloud management platform. The terminology around that's been shifting the last few years, but this rough idea that there's some place that you can go to say, I want a new batch of infrastructure configured, and generates that. Typically owned by like infrastructure ops and people like that. Bill will correct me on that. Whenever that kind of raw infrastructure is created for an application, that needs to tell your deployment pipeline tool, your release automation tool, hey, there's a new environment. And that tool needs to be able to catch that new environment and know what to do with it pretty cleanly. Otherwise, you're going to do a lot of configuration by hand, which undermines that whole value of cloud you're going for. Generally, then, your delivery pipeline tools are going to know how to call into service virtualization and test data management tools to kind of round out that environment. And they'll be doing that sort of work whenever you're running tests and putting applications in, is fleshing out everything around them. So that's the big picture. That's the introduction. I want to hand it over to Bill here, because I kind of assumed that like there's a cloud that you're using here, and that's a bit of an interesting question, right?
Okay, very good. Thank you, Eric. So I want to talk about cloud management platforms. So soak this in a bit. Rodney Dangerfield here at the end of Caddyshack. Have you heard this before? If so, who gets to make that decision? Is it central IT? Is it your line of business? Is it realistic? Is it likely? So as we see on the next chart, Eric, can you advance the chart, please? There we go. So as we see on this chart, hybrid multi-cloud is the future. That's the reality, and I think the numbers bear it out, right? So today we have a split of workloads, traditional IT, some in private cloud, some in public cloud, some in dedicated clouds. 94% of enterprises are using multiple cloud environments, public and or private. 67% have 2 or more public cloud providers. So why are enterprises adopting, cloud operating models? They're doing so in order to stay relevant, to create competitive advantage, to retain and delight their customers, and to maintain operational compliance and governance consistently across all their environments. So 20%, we estimate, of applications have already moved to the cloud, and those 20% are helping companies reap the benefits of reduced operating cost and accelerated innovation. That 80% remaining, they're kind of sticky. They're going to move more slowly to cloud operating models. So what we determined here is that IBM commissioned a study that revealed that the top 3 concerns of enterprises moving to the cloud are movement of workloads between clouds to quickly respond to changing business conditions, emerging opportunities, and evolving regulatory requirements. They're concerned about establishing secure and compliant connectivity between clouds, and then achieving consistency of management across all their clouds to reduce complexity and simplify operations and compliance. So hybrid multi-cloud technology gives enterprises the opportunity to be more innovative in their business innovation enabled by better applications and faster. Let's go to the next chart. So what are the challenges here? Surprisingly enough, some of the biggest challenges are not directly related to cloud resource management. They're about what happens when you try to adopt multi-cloud solutions across your enterprise. You're going to run some things in public cloud, some in private, Lines of businesses will take ownership and decide how they're going to deploy applications, while at the same time, you still need to take care of your traditional on-prem workloads. How will culture and people change? How will the tools change? How will processes change? So what we're seeing is the following. The culture is changing from central IT-led to DevOps and site reliability engineering-led. What does DevOps mean? It means lines of businesses get much more latitude in how they approach development and delivery of applications. We're seeing a Cambrian explosion of incompatible tools and operational complexity around deploying, managing, and governing applications around multiple cloud providers. That's a challenge. We're also seeing unified process models giving way to multiple best fit processes that are set up on a per line of business basis. So in the past, unified process models were attempted around idle models with the objective of creating a one-size-fits-all solution across the enterprise with a central heavy focus on central IT command and control. I think we all know now that that model is slow and inflexible. What's happening today is that the different lines of businesses within the enterprise are adopting and using different process models and different approaches for developing and deploying applications. This is creating chaos, and this trend to chaos and complexity ultimately is untenable in the long term. Next chart, please. So one of the tools in your toolbox to help manage this complexity might be a multi-cloud management platform. That platform should provide a consistent set of capabilities for developing, automating, governing, and operating all of your application workloads, regardless of where those workloads reside, either in public, private, or hybrid clouds. Ideally, it must support containers, VMs, cloud native services, things like Amazon Lambda, as equal citizens. You want to treat all those as equal citizens and have common capabilities. You want your cloud platform to support a diverse application management style, whether it's DevOps, site reliability engineering focused, or traditional central IT ops. There are some companies that have challenges moving to DevOps. You want to give them modern tools with the ability to stay comfortable with their existing process if that's what they need. You want to be able to support modern techniques like GitOps and managing infrastructure as code through dev, test, staging, and production, using a version control system to hold your cloud resource artifacts. You want a common, convenient data integration plane, a collection point for all of your cloud operational data to facilitate use of advanced analytic techniques for managing, governing, and placing your workloads across all the different clouds that apply across your enterprise. You want your cloud management platform to dramatically simplify operations to help you lower cost and improve compliance management. You need a tool that will let you or give you the ability to integrate the tools of your choice for monitoring and governing application costs and informing application placements. And finally, it must be REST API enabled, fully scriptable to allow you to integrate, the platform and the capabilities into automated DevOps tool chains. And if everything works out right, your management platform should also give you somewhat flexibility to migrate workloads to different clouds to help you mitigate cloud vendor lock-in. So, in review, the key design points. You want to be able to deliver applications to market with speed, efficiency, and consistency, with the freedom to move those applications across clouds as needed. Automation needs to be at the core, right? You want to automate everything. You need to address the different user experience needs of developers, of DevOps pros, of site reliability engineers, and traditional IT operators. with a thing like, a catalog, a portal, automated DevOps tool chains, and so forth. For efficiency, ideally, you want to eliminate silos across management domains. So, siloed developers for Amazon, for Google, for IBM. You want to try to level out those silos and make it easier to manage all of those different cloud vendors should you need to. Based on open standards, you want to avoid lock-in. You want to adopt open standards that apply and work across multiple cloud vendors. And then finally, it's great to have lots and lots of pre-built content from open source communities, from third parties, from IBM, for all your middleware needs, available at the press of a button to deploy in the cloud that best fits. Next chart, Eric.
Sure thing. And yeah, I like how you're talking about kind of that consistency and open standards, because this leads right into what's turning into the standard runtime for everybody. If I can click.
Okay, so here's a takeaway. Hybrid multi-cloud today is mostly about containers and Kubernetes orchestration of those containers. What we're seeing is organizations are adopting container-based solutions with Kubernetes as the underlying orchestration layer to reduce development and operating costs and improve application delivery. So some statistics behind that. We see that organizations are saving upwards of 70% on dev and test cost, 40% on production cost, while operating with 80% fewer servers. 66% of organizations who've adopted containers experience accelerated developer efficiency. 75% achieved a moderate to significant increase in application deployment speed. Next chart. What we're also seeing is that multiple clusters are already a reality. So gone are the days of having a cluster in a cloud. Enterprises are managing clouds and clusters that span public and private clouds, that span, geolocations across availability zones in public clouds, clusters that span across dev, test, and into production. Next chart. So as organizations deploy more clusters, Kubernetes clusters, new challenges emerge. So challenges around deploying, managing, and maintaining compliance for modernized applications across clouds. For enterprise customers, bridging the cloud divide from the traditional IT world to the container world is very, very daunting. At the end of the day, enterprise, they must have visibility into all of their clusters. They must be able to execute policy and governance across all of their clusters. Finally, they must be able to manage the life cycle of those clusters, and that management must be fully automated. Next chart. So what do I mean by visibility? So answering some very simple questions. Where are the failed components? Where are my services running? How can I monitor applications across clusters and across clouds? How can I manage clusters as if they were one environment? How do I monitor usage across clouds? Next chart. So governance concerns itself with the following questions. How do I set consistent security policies across environments? Which clusters are compliant and which aren't? How can I manage configuration across a very, very large environment? Hundreds or maybe even thousands of different clusters? And how can I place workloads based on capacity, based on policy requirements? Things like data residency or close to your end consumers. Next chart. In the automation front, how do I deploy applications across these environments consistently? Once they're deployed, if I need to move them, how do I move those workloads? How do I back up my applications? How do I do disaster recovery? So all these things are concerns and questions that you have to have answers to as you're rolling out an enterprise-grade cluster management. Next chart. So I want to take a look at three important use cases and kind of what they entail. So container-based applications really lend themselves to techniques of management that weren't available to straight VM-based applications. You can do things like application-centric management, where you can define and deploy applications that are dispersed across clusters based on policy. You can auto-generate dashboards that are fine-tuned to particular applications and optimized for applications. Next chart. Container-based applications also lend themselves to policy-based governance. So you can set and enforce policies for security, applications, and infrastructure. You can check compliance across clusters. For example, if a cluster is for production, you shouldn't allow developer access. And in the event that a developer is given access, you want it to be detected and revoked immediately. So policy enforcement should be automatic, out of compliance conditions quickly detected and remediated. Next chart. In the cluster lifecycle management, this is something you need to complete your picture. You need deep lifecycle management of your clusters. So you need the ability to manage clusters across multiple data centers, multiple availability zones, and in public cloud native Kubernetes services. You need to identify the health of all your applications across the clusters and get identified or get notified immediately if an application is not responding properly. You need to provide deep visibility into those problems and the ability to debug them and chase problems across clusters. And then finally, you need to enable cluster organization, scaling, rolling updates, things of that nature. Next chart. So I've talked a lot about cluster management, and as I said, that's really the future of hybrid cloud, but infrastructure doesn't go away. Your cloud management platform needs an answer for how do you provision, monitor, manage infrastructure. Some of the key concepts, in our opinion here, and you can go very, very deep on this as well, but the ability to manage your infrastructure as code using GitOps techniques to let you version infrastructure through dev, test, staging, and production, and doing it with a declarative cloud description language that you can check it into a Git version repository and manage the versions. This helps with compliance. This helps with sharing environments across your development teams, internationally, so that your dispersed development teams can be guaranteed to get exactly, the same environments to develop on. It needs to be multi-cloud and multi-architecture. You want a unified process for automating your infrastructure that works the same in all clouds, and you want it to be able to handle containers, VMs, cloud native services, network, storage, and it needs to be centrally managed and multi-tenant. Next chart. What are some other components you should expect having in a cloud management catalog or a cloud management platform? Another is a service catalog. You should have a service catalog that is rich with pre-populated, pre-built content and the ability to be easily extended. Open Service Broker is a great spec to build a service catalog out of. It allows you to develop and deliver cloud agnostic interfaces to services in a very consistent, repeatable way. The Open Service Broker spec provides a well-architected way to bind services together. So if you need to use your CI/CD tool chains to combine, a half dozen different services into a final application, you can do that through the Open Service Broker spec. You want to be able to build configurable services and pre-configure guardrails around some of the configuration option, perhaps for compliance purposes. A service might be restricted to a particular Amazon availability zone, and ease of use, just hide unnecessary complexity from the end users. It needs to be, your catalog needs to be able to hold both Kubernetes and non-Kubernetes resources. So it needs to be hybrid cloud, hybrid architecture, allowing you to combine Helm charts and Terraform, in any combination. You want to be able to, with your services, drive integrations to your traditional idle management tool, drive REST APIs and other integrations. And ideally, we'll speak to this a bit later. You want to be able to have tools to build these service orchestrations graphically. Next chart. Graphical design tools. So it's nice to have a good set of graphical designs tools to help your team accelerate application development. Since automation development, think Terraform configurations, OpenStack heat hot, and so forth, and service development are really two separate specialties. We think it's a good idea to have design tools targeted at each user. So for example, an automation template designer with a drag and drop UI can help automation developers code hundreds of lines of automation in literally seconds with a few mouse clicks. A service designer operates at a higher level. So the design primitives here are collections of service automation, maybe Terraform, maybe Helm charts that you can combine together, feed the output of one into the input of the other, and orchestrate the order of the bring up and the tear down of these orchestration flows. You want to be able to call out to REST API interfaces, to other things you might need to integrate with, Slack, email systems, CMDB systems, things of that nature. And you want to be able to build services that can be delivered as a cohesive unit into your open service broker catalog. So you should be able to build, curate, and expose services to your developers and your users in your broker catalog. And those services can be backed by cloud resources literally anywhere in the world, right? Any cloud in the world, anywhere that you can get connectivity to, you can build and curate and pre-configure and shape a service that is very, very easy for your development team to use. And they don't have to be an expert at the underlying cloud where those resources are being provisioned. Next chart, please. So this is my one and only product chart in this deck. So, this is the IBM Hybrid Multi-Cloud Management Platform. We have a complete platform stack at the top, starting with IBM Multi-Cloud Manager. This is our container management system, focused on policy and governance and automation of applications built with containers. We have Cloud Automation Manager. This is our tool built around Terraform, which we think very, very highly of as a modern GitOps-enabled declarative cloud configuration language that is not only handles basic compute network and storage, but also gets deeply into cloud native services and all the different cloud platforms that Terraform supports. We have Cost and Asset Manager. This is a tool that you can connect to your public clouds as well as private clouds, ingest all the utilization data, and we can present you in dashboards, the cost of those resources, what accounting center those resources or those costs should be assigned to, resource utilization, if we're talking VMs, are they underutilized? Are they approaching being overutilized? Also with a dashboard that will give you some prescriptive guidance to either optimize cost, optimize utilization. We have a rich enterprise content catalog with both container-based and Terraform-based assets with IBM middleware, open source middleware, third-party middleware, all setting on top of a consistent set of core operational services. So I hope that gave you a nice overview of a cloud management platform and what you should look for. And with that, I'm going to turn it back to you, Eric, to complete the story.
All right, thanks, Bill. And yes, sorry about that first slide. Yeah, here. So kind of hit those first two chunks, right? How do I get all of my VMs or containers, right? Or my containers running on new VMs, spun up with that middleware going in some cloud. And how do I pick which cloud? All right, so capture that. Now we still have the rest of building out that test environment. So this is where you've got your continuous delivery pipeline, your release automation kind of tools, right? So these are tools that need to understand what an environment is, because we've just spun up some large workload. And we need to understand this is a whole application, just like Bill was talking about, the management, the monitoring needs to be application-centric. So does your delivery pipeline. It needs to understand what an environment it is. And then it needs to be really good at doing integrations, because it needs to catch this new environment coming from your cloud management, and then be able to talk to kind of test sorts of tools as well as middleware in order to make all this magic happen. So it's kind of delivery pipeline, application release automation, application release orchestration are the tool categories to go Google. IBM's product in this space is IBM Urban Code. So again, drag and drop automation, clear views across your environments of what's where. All of this so that you can move quickly in time to market and have good audit trails and governance, so you're allowed to do it. So correctness, speed, and governance. Yeah, Bill said he'd done his one product slide, but he wasn't talking about me. All right. Then once you've got your kind of deployment automation in place, right? This is where we're going to move down and we're going to worry about data. So I mentioned earlier there is a kind of a category of either data virtualization or copy data management, this idea of how do I copy data around? That's kind of one category of tools. And then you've got probably the more formal area of test data management. And the goal here is generally to get the subset of data that allows you to validate that your application works without it being too laborious to get it. It shouldn't consume too much storage. It needs to scrub the contents exceptionally well, so you're not exposing to your tests sensitive personal information and things like that, which often leads to a strategy of fabricating data. Give me data that looks like something, because if I generate that data dynamically, I'm not at risk of exposing data copied from production. So both strategies, either fabrication or a scrubbing method, work really well. Both work in this tool category of test data management that we like a lot. The tools that we have within IBM are known as Optum Test Data Management, and they'll go ahead and pull down the production data, do the scrubbing. We do have a fabrication offering here as well, and I think what I'm seeing from customers, although I'm not as close to this area, is that more and more data is being fabricated than we saw 10 years ago, given the governance that we're seeing. But both models here are pretty common out there, and we've got some excellent tools. Other people have excellent tools. You kind of need something in this space, though. All right. Then we get into service virtualization, and I appreciate we had a question earlier asking, could you go a little deeper on service virtualization than you have? So I'll try to do that here. Right. The core idea really is kind of impersonating some service, some API. And that allows you not to need to be connected to that thing. This is good for the reason I suggested earlier, where you can basically save money, right? You don't call some public API that charges you per 1,000 transactions or something. Or you don't, you hit the mainframe when you're and burn a bunch of cycles there. The other key place that this is valuable is when you've got an existing application and you're trying to make it more cloud ready, right? I think Bill said, look, the future here is Kubernetes. 100% agree with that. And so what we see a lot of clients doing is they go to an existing app and they start containerizing it and they start pulling pieces off and making microservices, and they're making this application more and more cloud ready. They end up for some significant period of time though with the important bits have moved, but there's like some appliance they've got from a vendor, or some weird off-the-shelf software, maybe even just some piece of software they've written themselves. It's kind of difficult to lift into that world, right, for these larger apps. And service virtualization can go impersonate that component of the application as well, so that the rest of your app can take advantage of cloud, can give you that test environment on demand, can be fast, and you can get more of those benefits faster by virtualizing away the things that aren't ready to move to cloud. Where the service virtualization tools that are on the market are really interesting is generally you can point them at some communication between components, right? You can say, okay, I've got web service A, it calls web service B. What you do is you point A at the service virtualization tool and have that service virtualization tool then point at service B, and it can move the communication along, looking at the patterns of call and response and figure out, okay, if I get a request like A, I should respond with B. Cool. Now I can turn B off, spin up a virtual service, and I can do that impersonation really effectively without having to like write a whole bunch of code, right? And this is all about being able to do this in a manageable way, in a governable way, and in a way where you don't have to write as much code. So that's a lot of what service virtualization is about. Go and impersonate some other system, generate that capability with as little code as possible, as kind of little manual tuning as possible, so that you can shrink the size of your test environments, lower cost, and decouple from things that don't let you use cloud. Our offering in this space is Rational Test Virtualization Server. Does a really nice job in this space, and very much kind of API centric here. Like go sit between these APIs, manage these legacy tools, and these virtual services, they fit right into the same Kubernetes world we've been talking about all day, right? So you can run your new virtual services out in the cloud. You can spin those up as part of this larger system when you're doing a test environment. Generally, what we see here is users will use a lot of virtual services in early test environments and very few or none in late test environments. So the application becomes progressively more complete as you get out towards production. At some point, you probably want to test the whole system before you release it. All right. So we listed out a whole bunch of tools. One of the early slides I talked about was kind of saying, oh, you're going to have, your multi-cloud manager or the cloud automation manager. It's going to hand off new environments to your release automation tool. I think you guys can see my mouse. That kind of works like this. That's then going to call your virtual services and your testing tools, as well as hooking in and saying, hey, test data management, you should go do your test data management work, all in order to make sure that we've got this application deployed into infrastructure that's been provisioned for us with any virtual services we need and the data we need all ready to test, so that we can get a test environment on demand, run our tests, shut it down, and stop paying for that infrastructure. That's what it looks like at the end of the day. These are the sorts of architectures that we see our clients building. So that's, in summary, you want a test environment, it's a lot more than spinning up some VMs. It's a lot more than just running a Helm chart against some location and bringing up an app in Kubes. A lot of bits and bobs here. We're happy to take questions on any of that, as I think we're about to move into the Q&A section. We do want to encourage you, if you want to learn more about this, Bill and I are going to be together in San Francisco along with, I don't know, was it 30,000 of our closest friends? It's going to be awesome. This is February 12th through 15th, big IBM Cloud Conference of the year, IBM Think. So we're going to be talking everything from IoT to DevOps to cloud to security, down in the heart of San Francisco. It's going to be awesome. So if you want to drill into more of these topics, please come join us at the conference. I think we'll even have some folks from DevOps.com there as well.
Not me, though, unfortunately.
Oh,
sorry to say. But anyway, all right. So why don't we go ahead and move into the Q&A portion of today's program. We've gotten some great questions in so far, but there's plenty of time. If you have a question for Eric or for Bill, go ahead and use your GoToWebinar control panel, submit your question. Okay, let's go ahead and just dive right on in here. Let's see. Okay, this is a good one. I'm hoping to hear how using UC Blueprint Designer to help drive creation of and deployments to public and private cloud infrastructure. Not quite sure. That's not a full sentence there, but hopefully derive some information there.
Yeah, so Bill was talking about Cloud Automation Manager as part of the overall solution for kind of provisioning those VMs across multiple clouds. There are a lot of other key pieces: managing that infrastructure, doing cost across all that infrastructure, etc. Just the part of the Cloud Automation Manager that allows you to design the VMware or VM level environments using Terraform, hit a button and spin those up. That's also available with our deployment automation tool, Urban Code Deploy. So that's just a little piece of the big solution that does allow you to define the kind of VM type infrastructure in a graphical interface, point that at a range of clouds, press a button, and we spin that up. So that is a shared component across a couple of products that we've got.
Okay, great. The next question, instead of having a developer environment, another sandbox approach would be the developer as a tenant. What are your thoughts on that?
That's capital T, tenant. I see the question.
Strange.
Bill,
Yes.
Does that resonate with you?
Yeah, a little bit. So, I mean, the first thing that comes to mind when I read the question there from Nelson, I think it is you know, the cloud management platforms, multi-cloud manager, cloud private, cloud automation manager has a role-based access control system built around the notion of teams. And you could have a team of one, perhaps, that's a possibility. And, maybe you can use things like, Istio to help you, control the networking and, canary deployments and things of that nature. This is probably a rich topic, probably beyond what we can talk about here. So if you're going to be attending Think, there are people you can look up there, and they will bend your ear indefinitely on some of these subjects.
Yeah, and the follow-up question there from Nelson, I think does point to the Istio or software-defined networking kind of approach where, well, maybe you don't have a different place, right, that you're deploying a new version of your app. Maybe you're deploying that running right next to the live version of your app or the live version of a new microservice, right? And you're just using networking rules to see, does the new version of the microservice work well alongside all of the other services it's with? That's a very powerful technique, and I think you need to be in that kind of world if you want to be releasing changes to your applications 10 times a day. And so that's kind of the 10 times a day approach. If you're releasing once a month, like, you can't do that. You need dedicated places. I think a lot of people we're talking to these days are somewhere between I'm releasing quarterly and I'm releasing 10 times a day. And they tend to have 1 to 3 test environments as a result. But yeah, I think there's a very legitimate approach of, I don't need test environments anymore. I'm going to, quote, test in production, and I'm going to use my load balancer to keep me safe. But you better make sure you're not going to trash all your production data while you're doing that. And so it really depends on what the service is that's under test.
Okay, great. Next question. Is the solution only microservices, or I'm assuming he's saying, can monolithic applications be transitioned?
I think it's better as you move towards, I think microservices and Kubernetes like each other a lot. And it all gets better the smaller and more discrete your services are. Certainly, if you want to get to that 10 times a day world, then microservices are very, very important for that. But I think Bill and I spend a lot of time with customers who have, sometimes you say monoliths, but very often it's like, I've got 10 web services and they're kind of big and they all break each other. So it's not just one thing, but it's a big ball of stuff that's interrelated and breaks each other. And I think that is where you see these test environments being really critical and, can play there. Yeah, go ahead, Bill.
If I can add to that, Eric, right? So I don't think that there's one answer which is best, right? There's the idea of take your existing application, lift and shift it and move it to cloud. Then there's the idea of refactoring, an existing monolithic application into a collection of microservices and containerize it. And then there's the idea of taking a traditional monolithic application and peeling off pieces of it and, making them cloud ready so that you can, maybe distribute that application, a system of engagement, in a public cloud that has a secure connectivity to a system of record, and your data that resides, on a mainframe behind the firewall. So I think there is no one size fits all. It really depends on, what your needs are with regards to, modernizing that application, what you expect to achieve out of that modernization, the payback. So, it really depends. That said, we do have a tool called Transformation Advisor that you can, point to Java applications, and it will give you, in some cases, it will spit out, a full containerized application ready to go. In other cases, it will give you guidance that, this part of your application can be containerized, this part can't be. It needs to stay in a VM, at which point you can decide to refactor it, or just, containerize the piece that can and build, automation to deploy the VM part and tie them together. So I think lots of options.
All right.
Yeah, and I think we may have tried to answer the question behind the question. But if the question is just, can I use this stuff with a monolith and will it work? The short answer was yes, right? We talked about you can spin up some VMs in Terraform or AVM,
Right.
connect that into your release management tool, have that, populate some data, maybe some virtual services around that thing. All of that works on a legacy, quote, monolithic app just fine. We encourage you to move towards Kubernetes, but yeah, it all works across the range.
All right, great. Well, we have about 4 minutes to the top of the hour, so I think we have time for one more quick question. How would this IBM MCM toolset work with serverless architectures of the future? And does IBM Cloud itself have any serverless architecture offering like Lambda?
Yeah, great question. So I actually just answered that, in the Q&A room, but yeah, it does. And yes, it's important, right? So I think there are two things to follow closely. Apache OpenWhisk is an open source project that, the IBM public cloud, has that available. And I think Knative is something that we're paying really, really close attention to as well. So the short answer is yes. There's some out there today, and there will be more in the future. So stay tuned.
All right, short and sweet. With that, we're going to go ahead and close out the question and answer period. And I know we didn't get to all the questions today, but please know that Eric and Bill and the other folks at IBM will be receiving a copy of all the questions that came through. So I'm sure they'd be more than happy to follow up with you offline, or you can just go to IBM Think, and I'm sure that you can get your questions answered there. I do want to thank everybody who did submit questions. And as I said, I'm sure they'll be more than happy to follow up with you offline. Also want to remind the audience that today's event has been recorded. So if you missed any or all of it, or you just want to listen to it again, you have the opportunity to do so. We will be sending out an email a little bit later on today that includes a link to access the webinar on demand. The webinar is also going to be living on the DevOps.com website, so you can always check it out there. Just go to the webinar section on the website, click on demand, and it should be right there waiting for you. And then while you're there, please feel free to check out all of the other webinars that we have, both upcoming and on demand, and hopefully there'll be something, at least one other thing that piques your interest. Eric, Minick, and Bill, I forgot your last name. I'm so sorry, Bill Darfield. Please, thank you very much for taking the time today. I do appreciate it. And Bill Stoddard, I apologize for that. Thank you both for joining me today for such a great presentation. And this is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.